And okay, which graph represents a function? A function has to pass the vertical line test. So this fails it, so not a function. This fails it, not a function. This fails it, not a function. This, I draw a vertical line everywhere. It only touches at one point. This is a function. Any questions there? Find the exact value of cos 5.6. Again, first you want to work out what 5 times 180 on 6 is as a degree, which is 150 degrees. And just do cos 150 degrees in your calculator. That gave me negative 0.866. Then we square it, square root it mentally. Right, so square it becomes 3 over 4. Mentally square root means root 3 over 2. But you got to remember it was a negative. The answer is negative root 3 over 2. Any questions about that? Are you guys all good with that as well? All good. We remember it. Square it, mentally square root. Okay. The graph of y equals f of x is shown below. Okay, and then there's a little open circle there. Where in the domain shown does the curve have discontinuities? So obviously discontinuous at negative 2, because it's just going this way and then it stops. That goes down here. It's discontinuous at x equals 2. This is y, so this is y values, so these are not x values. So it says x equals 1. Be careful, that's not an answer. And it's also discontinuous at x equals 3. So x equals minus 2, x equals 2, and x equals 3. Any questions there?
I don't understand.
Discontinuous. So if something is discontinuous, you've got a graph. You see how that is, obviously it's continuous. It's not changing. Yeah. For it to be discontinuous, do this, and then let's say it's going to do this. Would you say that this graph is continuous or discontinuous?
Discontinuous.
It's discontinuous only because it obviously stopped somewhere and then started somewhere else. Doesn't just continuous just means it just continues. Obviously, there's no break.
Yeah. Okay.
Right? So here it's at negative 2. This is going on forever, and then all of a sudden at negative 2 it stops and it starts down here. And then you're going. It's all continuous, all continuous, all continuous. And then as it gets to 2, it stops and it starts up here. So it's discontinuous at 2 because there's an asymptote. It's discontinuous at negative 2 again because there's an asymptote. And then it's also discontinuous at 3 because there's a pause, an open circle, and then it continues. So it can't be 3.
So every curve, if it's a curve, that means it's discontinuous?
The curve?
Yeah.
You say if it's a curve, it's continuous?
No, discontinuous.
This curve, would you say it's continuous or discontinuous?
Continuous.
Continuous. Why? Why is this continuous?
It just keeps going.
Just keep going, right? Is there any pauses?
No. No.
Continuous or discontinuous?
I want to say discontinuous.
It has to be because the two graphs are not connected. So it discontinued somewhere. Discontinued right in the middle here.
Yeah.
Yeah, so it's not continuous. The graph's not connected. The graphs have to be connected for it to be continuous. This one
Yeah.
here. Continuous or not continuous?
Continuous.
Continuous. Okay. So then if I put an open circle, continuous
This.
or not? Yeah, because it goes, then it stops. This is not included, then it continues. Well, because it stops, it's not a full curve.
Or if it's a closed circle.
It's a closed circle, well that just means it's back to this, isn't it? Because it works. Closed circle just means it includes it. So they would not put a closed circle. That means nothing. That just means this.
Okay.
If this is discontinuous, this would be continuous. Cool. Clears that up. Yeah. Discontinuous at -2, at 2, and at 3. Any other questions? Okay. Statistics, we're going to do that next term. Probabilities next term. All right. The graph of g of x is shown below. Which equation could represent y equals g of x? Okay. There's 2, -1, -3. Anyone remember what the factor needs to be? Is it going to be x plus 3 or x minus 3 for it being a root here? What about if it was -1? Is it x plus 1 or x minus 1?
X plus 1.
So this is going to be +1. This is going to be x plus 3. And this is going to be x minus 2. So straight away, you would know that it's not this one. Obviously not this one. X plus 3, x plus 1, x minus 2. It's D. X plus 3, x plus 1, x minus 2. You guys want to recap why that happens if you've forgotten? Remember, these are called intercepts. And obviously, y equals to 0. So when you're solving, you're going to write x equals +2, x equals -1, x equals -3. So if you have the intercepts, you got to go the other way around. X minus 2, x plus 1, and x plus 3. Good stuff. That's nice and easy. Which sketch represents the graph of y equals log x? Okay. Hopefully, we'll remember that log x firstly looked like this. All right. That was our basic log x curves. So we know it can't be this one. It can't be this one. Those are exponentials. Right, so be careful. Those are exponentials. Now you're just tossing up between either A and B. And the only difference is the fact that here it's saying x is 2, y is 1. When x is 2, y is 1. Here it says when x is 4, y is 1. The easiest way, you've already you know the equation, which is log x on log 2. Hopefully we remember that from our log laws. We change this to log x on log 2. And then really, I would just sub it in. Sub in log 4. If it gives you 1, it works. Sub in log 2. If it gives you 1, it works. Let's try this first one. Log 4 on log 2. What does it give you? ln 4 over ln 2 gives me 2. So y equals to 2 when it's log 4. So we know this can't be the answer. But let's just make sure this one works. Log 2 on log 2 is 1, which is 1. So therefore, B must be the answer. And that would be the graph. All I did there, I just subbed in x is 2 to just check if the y values work. Otherwise, these two graphs pretty much look the same, don't they? They all cut at 1. They're all approaching this way. So pretty much exactly the same graph. The only difference is when x is 2, y is 1. Here, when x is 2, y would give you 2, not at 1. So it won't work. Not the right graph. Okay, nice and easy. Any questions there? Do we remember that the log curve looks like this? Hopefully, and the exponential curves look like this. Right. Number 8. Given that cot beta equals -5 on 9, and that sine beta is less than 0, find the value of cos beta. Okay, anyone have any ideas of how we're going to start this question off? If you're given cot, you want
Triangle.
to find good. Good, you got used to that now. That's great. So there you go. Cot is 1 on tan, which equals to -5 on 9, and then obviously you'll flip everything, so you can get actually tan beta, which is -9 on 5. All right, good work. So cot is 1 on tan, but that's useless because you can't use cot. You need tan. So there it is. Now you're going to use a triangle. I like it. Okay, opposite over adjacent. Be careful. And you have such a thing as -9 up here as a distance. Hey, has to be +9 over 5. What does the negative tell you? What does tan beta equal negative tell you?
I don't know.
It tells me that tan is negative. And then the second thing you have, it says sine is also less than 0, which means sine is negative, which means cos must be
Positive.
positive. Because if these two are negative, that means cos must be positive. So if you want to find cos beta equals to adjacent over hypotenuse, which is the square root of 9 squared plus 5 squared. I'm just going to take a good guess and say 81 plus 25 is probably 106. So root 106. Answer is C. Do we understand that, you guys? And the question said, just since we're here, the question did say to find sine beta. The answer to sine beta would be opposite over adjacent. But because we know sine is negative, your answer would be -9 on root 106. Any questions there? All right. Very good. Very good. Very good. Let's do the next ones. All right. Might not say nothing. Question 9a and b, real quick. You guys end up with 6x cubed 5x to the power of -1 over 2x cubed times 5x to the power of -2. Then try to do this further one as well. Okay. The first one, 6 times 5 is 30. X cubed times x to the power of -1. When you multiply bases, you add your powers, so that becomes x squared. 3 take away 1 is 2. 2 times 5 is 10. X 3 -2 is just 1. And then 30 over 10 is 3. X squared on x is just x. So that was an easy one, which I hope you guys got out. Not too much trouble. Express the following as a single simplified surd expression. Root 3 cubed. Root 3 cubed is like this, like pretty much root 27. 27 is 9 times 3. And then, of course, that gets broken up into 3 root 3. Root 12 is root 4 times 3. Root 4 is the same as 2 root 3. So plus 2 root 3. And then, of course, the answer is 5 root 3. (12), 4 and 3. Root 4 is 2, 2 root 3. 3 cubed is 27, 27, 9 times 3, 9 is 3 root 3, and then, yeah. Any questions? Okay, question 10, not for us, that's for next term. Question 11. Question 11, actually not part of what you're doing just yet. Oh wait, actually, for functions at turning point at the point inflections at distance for what? Yeah, no, not for what you're learning just yet. Differentiate the following. Do we remember how to differentiate? I hope. So go and try these. Just a clue for B and C, no surds and no x's in the denominator. So that's a bit of a clue for B and C. I'll give you a minute or two to just try them out and see what you remember. Okay, Giovanni, y dash, were you able to get it out?
I don't think so, but
6 times 2, 12,
12,
x
5
to the
to the
power
power
of,
of 5.
yeah, plus,
Oh, aren't they meant to combine after?
no,
Oh, okay. Then I got 24x to the power of 3.
yeah, that's it, done.
I thought you were meant to
It
combine.
decreased. No, done, that's it, finished.
All right.
Decrease power by 1. This one becomes 3x to the power of 3 on 2. Remember, no surds allowed. So that surd gets changed to a fractional index. And then y dash. 3 times 3 over 2. 9 over 2. X. And then you take away 1 from the power. So if you do 3 over 2 on your calculator, take away 1. That should get you a half. And this one here, negative 2x negative 3. And then again, you bring the negative 3 down, that becomes 6x, take away 1 from the power. And then if you really wanted to, you could rewrite this. That's full marks, but you could rewrite it as x on 4 again. And same thing with this one. You can write it 9 over 2 root x, because x half is square root of x. Giovanni, any questions there?
Just with the third, I don't know how you got rid of it.
How I got rid of it, so how I made it into a fractional. So
Yeah.
Index laws. So the rule was this. Write it down somewhere so you can keep this in mind. If I've got a third and there's a p on the top and a q on the bottom, then it's always going to be x, p on the top, and q on the bottom. So what's on the top here? 3.
3.
And what's on the bottom? If there's no number for your thirds, it's always a 2.
Yeah.
Not a 1, it's always a 2. So it becomes 3 on the top over 2 on the bottom.
Yeah.
Makes sense? So
Yeah.
that's the rule. And then you know the negative ones, you know these ones here? If they're positive in the denominator, they're negative on the numerator.
Yeah.
Okay. So yeah, x cubed becomes x negative 3. Yeah. Okay. Anybody else? Any questions? Okay. Probability, next term, like I keep saying, find the equation of the line which is perpendicular to this. Okay. Find the equation of the line which is perpendicular to the line and which passes through this point. Who can tell me what I'm going to write first, or what I'm even going to say first? What would I ask you guys?
Draw a graph.
Not necessarily, no.
The formula.
Yeah.
mx plus b.
Oh, no, you guys keep saying that one. That's
Y minus y1.
That's the one. This one here is a form. You got to wrap that around your head. That's a form. We don't want that. To find the equation of the line, we're trying to more do this. Y minus y1, mx minus x1. Where now there's a million ways of finding gradients, right? Just so you guys know. The first one is rise over run. Rarely used. The next one is y2 minus y1 over x2 minus x1. The next one is y dash, because calculus gives me the gradient. The next one is tan theta. That also gives me gradient. So you got to keep that in mind. And the last one is, if it was in this form, mx plus b, I can get the gradient by just looking at the number in front. So there's 1, there's 2, there's 3, there's 4, there's 5 ways of finding gradient. But that's the first thing I'll probably ask you guys. Find the equation of the line. Well, what is the formula for the equation of the line? And it's that, not that one there. Then I would say, okay, well, great. From this formula, we have x1 and y1. Sweet, that's done, that's done. The only thing is I need m. Well, you know, m is perpendicular to this line. Okay, so that means now I will go make this in this form so I can actually get the gradient, because I'm not going to be able to get the gradient through rise over run. I'm not going to get the gradient through y2 minus y1. I can get the gradient through calculus, because calculus can't fail you. I can't get the gradient through tan, so it's either mx plus b or y dash. I'm just going to do mx plus b because I think it makes a bit more sense with straight lines to just do it mx plus b. So move this over. You're left with 3x minus 7 equals 5y. Divide by 5. So your gradient of your, let's call it your tangent, is 3 on 5, which your perpendicular one, which we call it normals, is negative reciprocal. Negative 5 over 3. And then the rest is easy. Any questions for that one there? While I just finish this bit off. Times by 3. Bring everything to one side. Mickey, do you feel comfortable with that yourself?
Yeah.
That's good. Hopefully, you're starting to see there's also repetition in questions now. After you guys start revising weeks and weeks of revision, you'll start realizing the questions just keep coming up. They're the same questions, which is good. That's what you want. But yeah, nothing too fancy. Just got to know that that's the equation of a line, equations of tangents, equations of normals. They're all lines, so they're always this formula. It's just a matter of finding your gradient, and there's a lot of different ways of finding gradient. In this case, we just did it like that. And then because it's perpendicular and not parallel, I didn't use the 3/5. I did negative reciprocal and then just a bit of algebra to make it look nice. Okay. There's no questions with that one? Question 14. Question 15, again, I'll give you maybe a minute or two just to look at it, scribble a few things down, maybe even get the answer. Okay, so with algebraic fractions, it was all about the denominator. So a plus 2, factorize your denominator. And then once